Hello guys, hello world, hello Philippines. I'm coming back. Hello world, hello Philippines. Hello other parts of the world. Welcome to my YT channel. I'm coming back for the continuation of process safety information. I already did my cardiovascular, cardio exercise, my 30 rounds of jogging in a cricket oval, and I'm very, very happy that I did it. Okay. I will try to, wait for snow weight. Okay. For a while, I will come back discussing the process of information. And gosh, ladies and gentlemen, happy to announce that I am 62 kilograms. Oh my gosh. From 63 kilograms down to 62 kilograms. Okay. And then me full, busog. It will just lower down the next morning. Oh my gosh, the morning. Okay, let's continue directly. Okay. Okay, to recall that process safety information is very essential to conduct, to have the process hazards analysis. And this is one of the components of, or one of the elements of process safety management. Okay, we'll talk about process safety information. There are three information. Okay, there's no word information, right? Only information. Three information. First, the information on the hazards of the highly chemical hazardous, hazardous chemical substances used and produced in the process. Okay, this one. Oh, this one. Okay, we have the toxicity data, the permissible exposure limit of the PEL, corrosivity data, reactivity data, okay, thermal stability data, okay, and the hazardous effects of inadvertent mixing of different chemicals, and then the physical data, okay? Recap only. To information of the technology used in the process, of technology for the process. Okay, first is a black flow diagram or a black process flow diagram. Okay, the simplified process flow chart. Okay, like that. Okay, it's number two. Okay, process chemistry. Okay, like that. So you can read that one. Okay, maximum intended inventory. Okay, the safety upper and lower limits, such as the temperature, pressure, flow, concentration. Okay, like that. Okay, so the last one will be the check. Okay, an evaluation of the consequences of the deviations, including the health and safety of the employee. Now we go to the information of equipment, work equipment used in the process or for the process. Okay. So information I will write information of the equipment used in the process. So first we have the materials of construction. Okay. Materials of construction. Like that. Materials of construction is very important. We need to select the proper and the most suitable or the most durable type of materials, okay, of different vessels, different tanks, okay, different pipelines, something like that, that it could endure or resist any outside environmental factors, again, like heat of the sun, corrosion process, like that, okay, too much pressure, like that, too much air velocity, outside air temperature also, wind velocity, air, okay, air, okay, so those are outside environmental factors also, okay, so those materials of construction of the particular line to lines must be durable, okay, must last longer for a long period of time, okay, like that. It could resist to any uh, environmental factors that could destroy the integrity, the reliability of these materials. Okay, something like, or the conditions of the materials. Okay, number two, like that. Number two, we have the electrical classification. Electrical classification. Okay, we need to consider the electrical classification because some vessels, not some, mostly, okay, tanks, vessels, pipelines like that, motor pumps, okay, whatever, having electrical lines, okay. So we need to have good electrical classification that, for example, that it should uh, confront or conform to the standard, okay, the NEC 70 National Electrical Code. Okay, so it will follow the world standards regarding electrical classification or electrical materials to be used in the electrical connections like this in the wirings and everything because these are needed. Okay, it cannot operate without this electrical connections, of course, in the process. Okay, number three, we have the P and ID. Okay, P and ID is very common and popular in also in construction. We did a lot of inspection line to lines before. In my experience in Saudi Cayenne Petrochemicals, I've worked there also in Jubail, Saudi Arabia. So our job is I am the safety representative during the pre-startup, startup, commissioning, pre-commissioning. I will one of the auditors or safety representative that will evaluate regarding safety points and then before a certain system or a system line to run or operate, something like that. So they need my comments, my safety recommendations, blah blah blah, so on. So before this particular system or this line like that will run. So the safety parameters and safety criteria will be considered also. Okay, like that, along with the other team. Okay, like that from the commissioning team, like that from the production team, like this, a lot of a lot of departments will do the inspection including the safety, the quality is there also, okay, the QZ, something like that, the pipelines to pipelines, like the QC line inspector, something like that for the different pipelines also. We are one team during the inspection. Safety also will be there. And we are having the PNID, which is known as the piping and instrumentation diagram. We need to follow the lines to lines, for example, line one, line two, line three, and we need to check the valves. If the valves are, having a good placement or good positioning, okay, in the safety points of view like that, could it be reachable during maintenance, shutdown, or any kinds of job, preventive maintenance, whatever. So because if the valves are too high, and there's no platform, then how can the maintenance personnel will do the job during operation. So we need to check that one also. That should be accessible, reachable, and the orientation also of the different valves, something like that. A lot of valves, right? The check valves, the gate valves, the butterfly valves, something like we need to check that one. The different blinds, okay? We need in the connection, the flange in the connection to pipe, okay? The blinds, the slip blinds, the spectacle blinds, flange. It's like a circle, and there's a holes on the outside, like a circle, and there's a holes 1, 2, 3, 4, 5, 6, 7, 8, 10. Okay, and then we need to determine if it's an open valve or closed valve, something like that. Okay, so that's my work before in Saudi Kayan Petrochemical, SABIC. Okay, in Jubail, Saudi Arabia, something like that. Okay, so this is PNID, meaning it's a shortcut of piping and instrumentation diagram. Okay, like that. Number 4, we have the relief system design. Okay, relief system design. This must be a discharge, because if there's no discharge and vents problem, okay, it should have venting like that. Okay, so that the steam can release, something like that. Okay. Okay, and then we have the ventilation. Of course, if there's no ventilation system design, then overheating is very common. Okay, it should have ventilation to cool the particular pipelines, motor pumps, lines to lines, or work equipment. Okay, if it's running for, let's say, 24 hours, and then there's no ventilation, there's no air, so it will be develop an extreme heat, and it will be possible of damaging those work equipment, motor pumps, if there's no fan, of course. Common sense, right? Okay, so ventilation system design. Okay, this one, relief system design, ventilation system design. Number 6, we have the design code. We need to follow the design code also. Okay, a lot of codes are next 70, like that. NFPA number 10, like this. A lot of codes to be followed also in electrical and instrument, like this. In safety also, okay, and standards applied or employed. Okay, this is during with the design, of course. Okay, standards implemented. It should be meeting this particular standards. Okay, for example, ASTM, blah blah blah. ASTM, American Society of Testing Materials. Okay, it meets the following standards. It meets with NFPA standard, National Fire Protection Association standard, like that, National Electrical Code standard, and a lot, so many standards. Okay, globally, it should meet also the requirements. Okay, and then we have number 7. We have the safety system. This is our area, really. Safety system. We need to know this not only for the engineers that are not safety, but all engineers must know this, not only limited to the process engineer, the mechanical engineer, electrical engineer, or what we call the safety engineer must know this also. Okay, because this is process safety information. Okay, safety systems, the interlock. Okay, detection suppression system. Okay, here automatic safety devices. Okay, here safety systems, interlock, detection suppression system. Okay, for example, there is a leakage and there's a safety device that will signal and it will sound. It will alarm that there's a leakage somewhere along that line 1, line 2, line 3. So it's automatic. Okay, automatic system, something like that. So this applied here, safety system or other safety devices, not only for the leakages, abnormalities also. For example, if the level of the tank, say you are producing liquid products, and if the liquid products are high too much, so it becomes full, and then it will signals also, okay, alarm, something like that, automatic, and then it will be adjusted to the appropriate leveling, something like this. Okay, that's only example. Okay, safety devices, okay, for the alarm. Okay, and another example, so if totally drained also, no more liquid in the tank, and it will also alarm, something like automatic also. And it can be seen also in the central room, central control room. So they will signal also the field people. Okay, they will communicate the field people that it was totally drained based on their, in the data information center in the central control room. Okay, because sometimes those field operators are not there. We don't know, right? They go to the toilet, whatever, and then no, they don't see. So that's the time they will signal and call them like this, like this. Proper communication. Okay, so the safety devices are focused here, number 7. Okay, which is interlock detection suppression system. Here also, it's considered also the the alarm system, different fire alarm systems. Okay, smoke detectors like this. Okay, heat detectors, combustible gases detectors. Okay, like that. Okay, under here also. This is so many examples here. Others are not being mentioned, but these are all safety systems and safety devices for safety automatic. Okay, no need to watch every time. It will just alarm and signals, and then okay, it will be seen by the monitor in the computer, the central control room. Okay, and they will call also the safety. Okay, because that's related to safety, of course, safety systems. Okay, so that's number 7. Okay. Number 8 is material and energy balance. Okay, this is really related to engineering courses, right? How to do the balancing, input, output, recovery, something like that. Okay, energy, you have to specify the energy and you have to balance that one. Okay, material and energy balances. Okay, and energy balances. Okay, input is equals to output, blah, blah, blah. And then how many, for example, how many cubic meter, if you're producing a product which is liquid, then how many tons or how many pounds that you will feed, okay, to the inlet, and then to go to the outlet like this, blah, blah, blah. And then what is your final volume in the output, something like that. And then there's a calculation, okay, for that, okay? And it will undergo a process, something like that. Okay, so like that. So a lot, and there's a lot. Physical chemical separation process will be there, and the products will be there in the final stage. Okay, this material and energy balance. Anything you put in the inlet, that is already a material or an energy. Okay, that's why material and energy balance. It should have be a balancing of the input and the output. Okay, something like that. So in our chemical engineering, we call this as overall material balance, something like that. Okay, this is number 8, material energy balance. So this is very important, right? Information of the equipment, right? Information of the equipment used to the process. So these 3 are very important. You need to know the information of the equipment used in the process, the information of the technology used in the process, and the information of the hazards of the chemicals, okay, used in the process and produced in the process, okay, something like that. Okay, these are only 3, but others also will be determined, not only this, okay. As I mentioned a while ago, there are 6, right? If you still remember in the introduction, we have the process first, what kind and what type of process, and then the whole process, okay, and then the sub process, you must know also sub, Okay, meaning so many processes before having that one single process. There's a lot of also process there. Okay, but that process are not really that large enough. Only minor, and then 1, 2, 3, 4, 6, 7, 8, 9, 10. It will come up to a one universal process. What we call it, processing or producing of, for example, cement. Okay, your process will be the production of cement, but somewhere along the way in the inlet, somewhere on going to the the crusher, something like that, going to the material proportion, mixing, like that, going to the preheater, going to the clean area, like this, going to the cement mill, oh, okay, like that. Okay, and then go to the final packing, and then the product will be there. So there's a lot of process, right, involved, but only one general process, which is production of cement. Okay, so crushing, grinding, like this, blah blah blah, heating, pyrolysis. Okay, that's why there's preheater there. Okay, in clean kiln. How can I pronounce it? Kiln, kin or kiln? So that's really very hot. Okay, so more than 1,000 degrees Celsius, something like that. Okay, so there's a lot of processes before you can produce the cement, something like that. That's what I mean. Sub processes involved before having that one general process. Okay, like that. So those are specifically could either be a physical and chemical separation processes mixed. Okay, because in the physical separation, that's only the isolation during the grinding, like that. That's physical. That's not chemical yet. But when you mix that there, it's already chemical there in the pyrolysis, in the burning. Okay, it involves chemical reaction there. Okay, so that's why it's chemical already. Chemical separation process is there, and it will separate blah blah blah, so and so. And okay, so that's why. Okay, it's under also material energy balances in this. Okay, so like that. So PSI. Okay, you should know the process. Apart from this, you should know the type and kind of process and the sub processes or the components processes, and then we should know the process equipment or work equipment involved or that used in the process. Okay. Number three, the specific materials involved in the process, or specifically the raw materials that you'll be able to feed in your process in the input side before it will go to the output side. So that's number three. Number four, we should identify the people involved to operate those equipment, to handle those materials. Of course, if there's no people, it will never be running smoothly. Okay, not all will be done in automatic. It should having a manual handling, and the people will be important also to operate the equipment, right? So you should know also the people involved because it's very necessary for your process hazards analysis. Number five, you should know the specific work area, okay, of those persons, because if there is accidental incident will be happening, you can easily trace that this is area A, area B, area C. Very easy to investigate, something like that. Okay, so the people involved, and then the work area, specific environment. That's number six, like that. So there's six you have to determine, including this PSI also. Okay, so nine. So there are nine of components or elements that we need to know to be applied before doing the process hazards analysis or the PHA. Okay, so meaning you cannot conduct the PHA without PSI. Okay, the process of information, meaning a written information to identify really the workplace chemicals and process hazards together with this equipment used in the process, technology used in the process, blah, 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 so on. So, okay. And another thing also, not only nine, there's still 10, 11, yeah, plus two. Okay, we need to know the workplace assessment. Okay, workplace assessment of the hazards of the chemicals involved. Okay, for example, if you are really dealing with raw materials that are hazardous, okay, there are things like that also in, for example, in the SABIC, okay, they are producing chemicals, petrochemicals. That is, the raw materials are petroleum, but they release the products solid. Okay, so that is what we call petrochemical because the chemical produced are driven by petroleum. Okay? The raw material is petroleum and it produces a product which are chemicals. That's why it's being combined petrochemicals. Okay, you get the point now. So there's a connection between petroleum and the chemicals, and the product will be petrochemical products. For example, polypropylene, olefin, okay, HDPE, high density polyethylene, polyvinyl chloride. Okay, those are the products of Saudi Kayan and Sabic industry, something like that. Okay, those are hazardous chemicals. Okay, like that because this polypropylene used in making Tupperware or will be used also in the plastic industries, okay, as the raw materials also. See, their products will be the raw materials also for other manufacturing companies that are producing Tupperwares, okay, plastic lunch bags, like that, polyvinyl orange pipeline, right, PVC, like that, an HDPE pipeline also, which is very good in underground pipeline. Okay, HDPE is the most very effective underground piping. Sorry. Okay, and it's costly also, something like that. See, their products will be the raw materials, will become also the raw materials for other. Like it's only a connection interrelated with each other. Okay, something like that. So we need to conduct the workplace assessment of those suspected chemical hazards in your workplaces. Okay, like that. And then after that, it will not be end like that for your assessment for the hazard. You need to have your mitigation, reduction, control, okay, and prevention systems. What you are trying to prevent is the accidental release of those hazardous chemicals. It could be gases, it could be liquid, it could be gas. Again, three phases of matter always. Always remember that in a process, it involves always three phases of matter: solid, liquid, and gas. Okay, because chemicals are always having three phases of matter. Okay, so these are manufacturing industries. Okay, if your product will be gas, gas. Okay, if your product will be liquid, liquid, something like this. Okay, so this will be the release for this are very, very dangerous. Accidental release. Okay, leakages in the environment like this because it will cause sometimes, not really sometimes, really explosion, fire explosion, and then one time your plant will be like this, just like one big bombing. If you will not take control of these things I discussed a while ago, if you will not take control of that, and then you will not serious, then something will happen because this involves calculation, engineering and calculation, and especially science also, and safety, of course. We need to prevent the work process accident or the process event so that there will be no catastrophic events. Okay? Catastrophic events are the loss of life and the damage of those properties due to the loss of containment during the, explosion of the vessels, the tanks, or the pipelines like that. If you are not taking control of these parameters as here, then problem. All are discussed here can save the plant operation. This one, even though it's only this, you can save the plant operation. Okay, this PSI only. Even though this PSI only, you still not conducting the process hazard analysis. If you try to implement this process safety information, then bingo. Okay, it's already safe and reliable, plant operation. Then much better if you conduct the process hazards analysis because you need to try to anticipate the danger, okay, the hazards and the rest. Now, and then you can say a careful review. What could go wrong? Oh my God, what's wrong with this? Something like that. What's the abnormalities? Then you can troubleshoot. And after you know the abnormalities, what could go wrong, then it's easy for you to implement the safeguards, okay, or the control measures or intervention measures, okay, so that there will be no accidental release of this highly hazardous chemicals, which are flammable, reactive, toxic, and explosive. So these are the, the properties, the chemical properties of chemicals. Okay, like that. I'm talking for the process, huh? Okay. Because in OSHA, there are 130 chemicals being there. Then if your company is not listed there, then you are not required to do the process hazard analysis because there are only 130 listed there from A to Z. Okay, they regulated that one because in November 15, 1990, so they established the Clean Air Act Amendment, CAA, and then the OSHA USA are very proactive to this. Okay, and this will be the basis entire the world, though it will not add, an obligation to other countries, but they use this as a basis globally. The OSHA, okay, this Clean Air Act Amendment of November 15, 1990 was used globally as a standard to adopt, though it is not really an obligation for other countries, especially countries that are not belong to USA. Okay, for example, in a European country, Middle East, Asian country, we are not belong to the States of America, right? But still, we are following their OSHA standards as our basis. Okay, our parent safety standards. That's why we cannot penalized. Okay, because that's another territory. But we are just following their standards, OSHA standards, okay? Because in the USA, United States of America, if they will commit something violations to safety, they will penalize the company, okay? They will close the company, they will fine US dollars for the company not meeting for this particular standard of Clean Air Act Amendment, blah, 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 and others also standard. But that will not be applied to other countries. Middle East, European countries, Asian countries. But we are using as the basis, our foundation in following the safety standards and legislations. Okay, our guidance, something like that. Okay, so we are using because if there's no guidance, then we cannot do our, our processes in an organized and systematized manner, and then there will be no safety. Okay, and there will be no safe systems like that, and there will be no also quality. Okay, it's related with each other, as I mentioned a while ago, right? Safety, quality, and productivity shall be given equal treatment. Above all, is the top priority is the safety, something like that. Okay, so we go to the process hazards analysis. Okay, the process hazards analysis is really using the chemical safety standard because this chemical safety standard are created and developed by OSHA, Occupational Safety, Health and Administration, in conjunction to the Clean Air Act of November 15, 1990. Okay, so they established this one. Okay, just because they want to prevent the accidental release of highly hazardous chemicals that could pose serious threat or adverse or fatal effect to the employees for the manufacturing companies that deals with chemicals, something like that. So this chemical safety standard will be the basis for our process hazards analysis. Okay, you get the point now, something like that. And then this chemical safety standard, we should know also the two complementary standards by OSHA, which is the HAZCOM, Hazardous Communication System, okay, which is 29 Code of Federal Regulation 1910.1200. This is the hazardous communication system. There it is being discussed that the employer must conduct a written risk assessment for all your chemicals used and involved in the process, something like that. Okay, if there's no risk assessment for the particular chemicals used, then you will be penalized by the OSHA. Okay, something like that. In that territory, in the United States of America, they're very strict regarding that one. Okay, and we are applying only to that also, but not more on the monetary penalty, but more on the system and procedure we apply. Okay, because we cannot close the company. Okay, just because of that. Okay, we cannot find also fine FINE. we can find money for that. For other countries, I'm talking only for the, the OSHA. Okay, so in that HAZCOM, abbreviation of hazardous communication, that is HAZCOM system, 29 CFR 1910.1200. It's very, very important to have the hazards identification of the chemicals. Okay, hazards identification, the hazards rating of the chemicals. And we will try also to connect. Sir Sotero, what are those hazards identification rating? And now that's the time we will talk about the NFPA 704, National Fire Protection Association Standard 704. For example, the diamond, okay, the blue represents health hazards and toxicity. The yellow represents the reactivity, or how stable or unstable the chemicals really are. And then the red will be the fire hazards or the flammability ratings of certain chemicals. And then the white is the specific hazards. Could it be a corrosive? It could be a acidic, alkaline, or could it explode if you add water? That's why there is W, and then there's a underline in the center. That means you don't have to put water on that particular chemical because it will explode. Okay, you have an idea already, and it's reflected in the tank. Usually the fuel tanker, like that, the crude oil tanker delivering crude oil in different companies, something like that. So if you see that on the road, there's like a diamond color coding. So that's the relevance there. Okay, if there's a W and then there's an underline in the center, meaning to say no water is allowed to be used because it will explode that chemical. Okay, so we need to know that in conjunction to the HAZCOM communication standards, and we really, really need to know that to be applied in the process hazards analysis. Okay, so like that. So the process hazards analysis is equivalent to the job hazards analysis in the construction industry. Okay, because construction industry are not dealing with chemicals processing. They're only dealing how to build the buildings, how to construct the buildings, how to construct the pipeline, how to construct the platform, how to construct the tanks, like that. They're not dealing on processing chemicals, right? That's why job hazards analysis. But for the manufacturing industry, we are using process hazards analysis. Okay, so they will not employ this process hazard analysis, only the manufacturing and operation company. Okay, but the process company or the manufacturing company can employ still the job hazards analysis. Okay, because this is the hazards being analyzed for the people during working in that particular plant. Okay, so meaning to say, if we try talking about systems and procedures, there's a lot of system and procedures applied in a running plant compared to the construction industry. But the construction industry are so very strict in the inspection and auditing because very not systematized, so many activities in the initial stage, right? So civil work, something like that, MEP works, like that. So many works there because that's an initial stage. Okay, so that's why it looks like very disorganized and very critical during the lifting of this very heavy vessel, like that. Okay, but after that, no more. Okay, because there's no construction that will not be finished, but the process is still there. Okay, continuously. So you need to monitor the safe system continuously because it's operating until we don't know 5 years, 10 years, 15 years. But the construction will end. Okay, the construction will end the project after 2 years, after 3 years, and another like this. But the manufacturing is not like that. So meaning to say, hazards and risks in the manufacturing companies are continuous. Okay, but for the construction industries, it will stop because their contract will stop also after finishing the project. But it is very strict in the initial stage because a lot of construction will be done. Heavy lifting, critical lifting, tandem lifting, blah, 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 so on. So excavation, underground, very deep excavation. okay, very critical scaffolding, like that, okay? So, blah, 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 so and so. I don't have to mention everything, okay? Like that. So, that's it, okay? I mentioned already the process hazards analysis, okay? And then we need to know the other, this one, the hazards. Cannot go there, the detail there, because these 4 components really are too long. For example, I will give the example how to make the process analysis. 1, 2, 3, 4. Too much. It will take time, really. Okay, and I am alone. if you are alone, it's not easy to make because only one mind or only one head is not good. More heads are better than one. That's why we have brainstorming, right? We can choose the best ideas. If we have so many people inside the room or inside the making the document, that's more better, right? Because this process hazard analysis are really a collective effort. Okay, not only for one people to make this one. It should be representative. For example, representative of the mechanical, okay, the representative of the electrical will be there, the representative of the instrument will be there because there's a lot of transmitters also to be connected in the vessel. For example, pressure transmitters indicator, volume transmitters indicator, a lot, right? Level indicators, it needs instrument connections, okay? So it is necessary also, they will be there along with the safety, okay, in making the process hazards analysis. Not only, this is not a solo, solo creation. Wow. This is a, collective effort of every department to come, something like that. Okay, just like the hazards. It's not only a single person will make this one. This is collective efforts sitting in one room, and we can have our one hazard document for our plant, something like that. Okay, this will not be made by one person alone. I'll tell you frankly. Okay, it involves mechanical, electrical, because technical. This really involves technical, especially for the parameters. Okay, regarding safety devices. Okay, the controls like the parameters, the temperature, pressure, volume, like that, concentration, the flow, the density, and the electrical connections, blah blah blah. So answer the mechanical connections. Okay, the lot of flanges to be used, valves, different types of valves. Okay, we need to discover that one. Okay, but the risk assessment, it can be made by one person only. It will be okay. The Java hazardness, it will be okay, and also the risk assessment. Okay, but this is not really. It involves technical. Okay, for example, process A. So what are the parameters there to be checked? So what is the problem here? Maybe the density of this chemical will produce an effect, this blah blah blah, like that. Okay, and then we need to solve this one. Maybe the pressure will affect also if the concentration of this chemical that will go to this line, blah blah blah. You have to really have the technical information, okay, for that. Okay, not really only one person will make these hazards and the PHA. But for the risk assessment and construction, it's very easy, okay, because there's no process there. Okay, there's no running process equipment. Okay, you have to only the people, and always like this, construction, excavation, lifting, like this, always like that. Okay, scaffolding. Okay, like that. But in the process, it requires technical aspects, especially engineers will do this. Okay, for this process hazards and analysis and the hazards operations, it back up with education and knowledge, really. Okay, and training. Apart from the experience of being a process engineer or a process safety engineer, something like that, along with the other engineers, right? Mechanical engineers, so it also have knowledge, engineering knowledge, something like that, okay? And the training knowledge, skills, and experience, okay? Like that. That's why they usually hire engineers for that, okay? Like this. Okay, so this one. So I need to draw a flow process. So we need to understand really, Sir Sotero, what are those process hazards and risks we're going to determine? Okay, and you will be confused, something like that. Okay, so we need that to prevent the process events so that there will be no catastrophic events that will be happening. Because if there will be a catastrophic events, the loss of life and there will be a company losses, and then badding, or after that one, there will be a bankruptcy and closure of that plant because it was not managed very well, especially in the safety aspects, quality aspects, productivity aspects, something we need to, to be balanced in everything, something like that. Okay? Okay. Ganon. Charot. Ganon siya. Wow. Okay. So I will draw a process flowchart. This is only a generic process flowchart because I don't have to specify what kind of product we will be producing. This is an example only, an idea only, not really that specific, okay? I will just put A, B, C, blah, 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 okay? Like this. Okay. So process, right? So we have the input here. Input or the feed. Usually the input or the feed, F-E-E-D. So these are the point where you're going to feed the raw materials. Okay, any kind of raw materials. So if you feed here, it's understood there are equipment, there are technology, there are people involved, there are specific materials involved, like that. All the parameters I discussed a while ago, the 9 aspects will be in process A. Also, process B, process C, and then the last process and a final product will be there. Okay? You get the point already? And then each process we need to identify the hazards and the risks involved by those 9 elements that I discussed a while ago. So meaning to say, this is really what do you call this one? A very detailed and comprehensive hazards analysis. Okay, because there are 9 components I discussed a while ago, right? And the process of the information have so many examples also. So this is really requires thorough knowledge, skills, experience, something like that. Okay. So this is the input. General only, ha? Okay. And then like this. I don't have to mention the process. Okay. It depends on the process kasi eh, di ba? Okay. For example, in fermentation industry, there's also another process there. Okay. Like the in mining industry. Okay. Okay. The important is you have to understand. Okay. It's gonna be like this. Wow. Okay. Input process A, process B, process C is equals to output. Then this process A involves could either be physical and chemical processes. This B, the same thing, physical or chemical processes. C, also physical and chemical processes, specifically separation processes. For example, you need to separate the liquid to the solid because your main target, your product is solid. Okay, but your raw materials are mixing with solid and liquid. So you have the separation between the solid and the liquid. So you have filtration process, something like that. Okay, and you have also the extraction. Okay, like that. You have also the crystallization, and then budding, you have also the distillation process. And then there's also heating. Okay, pyrolysis. Okay, burning of the raw materials. A combination like that. Okay, so that will be like that. So this is an example only. In this process A, the input first. Input first, you need the raw materials, right? General, ha? Raw materials. Okay. The raw materials are being input in the feed here, being inputted here. So the raw materials, we need to, determine also their physical and chemical properties. Could it be hazardous? Could it be toxic, flammable, reactive, radioactive, and XA? You need to consider that, okay? And then you need to consider the outside physical factors, okay, which is the temperature, okay, hotness or heat, okay, the pressure, the volume, the density, the mass, something like that, and the flow or the concentration of this raw materials. A lot to be considered, right? It's not easy, okay? Like that. And then you also to consider the people involved here in the input. Who are the people who will be dealing the type of work here in the input? So you have also to classify them. Okay, the one who operate in the input people, because they are the one who receive the injuries if accident will be happening. Okay, then we need to to have control measures. We need to protect them. Good if that input has no people involved, meaning automatic doing the task. But nowadays, it's not all automatic. There's still people involved, really, okay, in the process. Though automatic, but there's still people around there. Sure, okay, like that. Especially in handling the materials, the specific materials, like that. Okay, by manual handling, like that. There's also mechanical handling, but the time they deliver the materials on the ground, it will be carried by the person, not equipment anymore. Because if the equipment will do very big, very huge, so sometimes it could be handled. Not sometimes, really, the manpower needed to handle the materials also. Okay, again, we need to troubleshoot what are the hazards of this person in handling these chemicals, inputting in the input, like that. Okay, very difficult, right? Because you have to very so many things to be discovered. And also in this area, you need also to troubleshoot the hazards and risks in this area, the work area. We are finished now with the people, with the materials, the work area, and then the equipment here also, the technology involved here, and the raw materials. So 6. Okay. You should write that in your process hazard analysis. So 1, 2, 3, 4, 5, 6, process A. Ganon. Okay. Process A, process B, the same thing. You need to consider the materials being inside here, okay, the work equipment, the system, the lines, for example, this is the pipeline. You need also to identify what are the hazards in this pipeline. Of course, you need to open your eyes. So normally leakages will be there. Leakages, L-E-K-G-S. So the leakage will be in form of liquid, solid, and gas, not limited to liquid. It could be solid, liquid, and gas. Then you have to report something wrong if there are a lot of leakages here. We don't know. Okay, like this in this line. So we need work equipment again, people, materials, okay, and the safety parameters, temperature, pressure, volume, density, like this, so on. So, and then B, C, and then in the product. Okay, and then you summarize that one. You can come up with a one process hazards analysis in your document. Then in your process hazards analysis, you need to have a column there. Column, okay, what you observe, what could go wrong, what are the abnormalities, what are the hazards, possible hazards in each process. Okay, what are the hazards and what are the people involved like this who will be affected and who will take the action to rectify those hazards and risks in each process. Okay, like this. And then you need to have also the risk ranking. It could be a low risk, a high risk, and then medium risk, and then until the output. It's just like that. You have to make a column like this, blah, 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 so and so. Okay, so it's just like that, but it cannot be made by one person only. It is a interdisciplinary approach, collective efforts in making this document. Okay, process hazards analysis. Okay, like this. Very clear now. In construction, the same also, but they're not really talking with process. Okay, only excavation, lifting, construction activities. Okay, like this, crane operation, blah blah blah, working at height. Okay, like this. There's a little bit difference. Okay, but the main difference is talking about the process. Okay, like that. So in construction industry, they are making the job hazards analysis or the job safety analysis and the risk assessment. Okay, but in the process, so many things to do. They also make the risk assessment, process hazard analysis, HAZOPs, okay, GHA also, like this. There will be more additional to be made in a running plant compared to the construction industry. But it is more dangerous in the construction initial stage because a lot of work to be done there in the initial stage. Very disorganized. That's a very strict implementation of the permit to work system, very strict implementation of the safety inspection and monitoring by the safety officers, like that, compared to the running plant, because it's like a normal stage running plant, only small things. If there are only, repair, shutdowns, abnormalities, that's the time we need to do the job, but not all the time, okay? But construction is all the time, okay? Because it's not being completed yet, okay? Like that. So that's only the difference, okay? So, but both are having the major hazards, of course, and the major risks, okay? So that's a little bit different. Okay, now like this. Okay, this one finished already. The PSI, the PSM hazards, and PHA. Okay, now I will be able to discuss a little bit with the process safety management elements. That's another thing also. Okay, so the plant or the manufacturing company, okay, there is what we call as the management commitment first above all things. Management commitment and responsibility, that's the first thing. And this is the main function of the owner of the company. Owner. Okay, so he has really the management commitment and responsibility to provide the safe place of work to the people, the safe work equipment to the people, the safe technology and facilities to the people, the safe work environment to the people, and the safe materials needed to operate in that plant or in that kind of factory. So the success lies with the head, right? Not on the feet. Okay, it's always the brain of the operation is from the top. Okay, so if the top is not really that good and strong, then the lower part will be affected. Okay, something like that. Okay, it should be in the top. So this management commitment or responsibility, it's always in their mission and vision to have the risk management of the business. Because if there's no risk management, so they will never be successful in their business operation. And there will be no sustainability after 10 years, after 15 years of their job because of their business, because there's no risk management control. Because risks are not only limited to the accident, there are also risks with the business. Okay, point of view. Okay, risk in business operations regarding what are the barriers, or any competition to the market like this, what are the risks if your products will not be sold? So what can we do this? We need to have a good research development office so that we can compete with other companies that we have the same products, okay? Because the consumers are not buying your products and you have to convince them. So the only thing to do is to hire a very good research department, okay, for your product to design properly, the quality like that, okay? So that's the thing, okay? So we need to have the risk management of the business operation and the health and safety environment sustainability. So I will draw now the schematic diagram for you guys like this. So any company has a mission and vision statement, okay? Always like that, okay? There's also a mission vision statement for environment, mission and vision statement for safety, like that, okay? So this is circle, ganan. So the safety management commitment will be at the center, okay? No, sorry, management commitment, not safety commitment, okay? Management, commitment, and responsibility, okay? Okay. They are the brains of the business operations for its sustainability, okay? It's not the lower the lower or the workers or the employees are the asset of the business operation. Okay, but they are not the brains. The brains really are the top management commitment and responsibility. Okay, the owner of the company are the brain. Okay, like that. And this is here on the other side will be the here like this risk management. And then here will be the, shall I say OSH na lang siya, right? Or OSHE, right? OSHE, sustainability. Okay? So, occupational safety, health, and environment, sustainability. Ganon. Look at my drawing. Okay? The center will be the management commitment and responsibility, and the outside the circle will be the risk management and the occupational safety, health, and environment, sustainability. Okay, like that. So this management are committed to these two components. Okay, and this two components will not be operated without the sorry 14 elements of the process safety management. Okay, so that we avoid the catastrophic events that could result to company losses. Okay, that can eventually cause the company to shut down or not in business anymore, something like that, or bankruptcy, closure, because they are not considering the risk management and the OSH and E sustainability. Okay. Okay. But what are those 14 elements? Okay. This is specific, 14 elements. I remember this come out in the National Examination of Board Occupational Safety and Health. A yogi examination, this come out. Okay. And, Nibush examination in July 2012. I taught that in Abu Dhabi. Okay. UAE. So this kind of question, I remember it came out to the examination. The 14 elements of process of elimination. Good at I studied that ahead of time, then I answered well. Oh my God. "14 elements of process safety management." During my discussion, if I'll talk about OSH, it's somewhat kind related to Nebusha, the way I discussed. It's Nebush related, OSHA related, something like that. Or the OSHA's 18,001 2007 related. The atmosphere of my discussion will be like that. I link that there always. Okay? I did not link more on the bush and the construction in the Philippines because, I'm not working in the Philippines as an occupational safety health professional. If I will study and read, but I am more, with this international, standards. But for the generic, I can still be more or less the same. Generic hazards, rest, like that. Assessment is generic, right? But for the specific, for example, DAO 1467 in the DOLE memorized, or I did not read that because I am not working in the Philippines as a safety professional. Okay. So I'm not good really for that, for our local safety standards and legislation in the Philippines. But if we talk about making safety procedures or safety manual or safety policy, I can manage only for the specific, specific safety rules and regulations related to the DOLE, Department of Labor and Employment in the Philippines, like this, right? Or the BOWC, Bureau of War. What's that? What's the definition? I forgot. Bureau of War Committee, BOWC. They are the one who regulated the OSH in the Philippines. And the dole, together with the dole, something like that. The rule number, blah, 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 rule number, blah, blah, blah. Mapimalo for that, okay? Okay, these 14 elements of process of safety management. So we need to establish first what standard is the PSN based on OSHA, right? That is 29 Code of Federal Regulation 1910.119. Okay, so 29 Code of Federal Regulation USA. Okay, international. Okay, 1910.119. Okay. Yeah, I have to memorize specifically because I need to do it because, you know, I need to justify in everything that I'll be able to discuss what is really the standard for that. Okay, because just like a lawyer, you need to state the what article is that, and then you can present the context and the contents of that particular law. Because it's not easy to it's not good also to talk directly with the content and you didn't even know the number of that article number, blah blah blah, right? Just like that. Okay, so I really suggest safety professionals to do that. Okay, to memorize the basic OSHA safety standards. Okay, so that we can really defend our safety functions. We can easily execute our job functions well. Okay, something like that. So this is the standard for the process safety management, a specific safety standard management. Okay, 29 CFR, Code of Regulation, Federal Regulation, sorry, 1910.119. Okay, like that. So it's in there, it states that it is the responsibility of the employer or the management to really manage, okay, the operating systems with respect to its reliability and integrity, okay, specifically in the process or handling of highly hazardous chemicals, okay, by applying good design, take note, good design principles, okay, engineering, okay, and safe operating procedures, or what we call as the safe work practices. It's being really specified in OSHA standard, okay? That is their main responsibility, okay? And then the other responsibility in complementary to that is to manage the process hazards and risks to prevent, okay, the accidental release of these highly hazardous chemicals, which are toxic, flammable, explosive, radioactive, okay, like that, always like that, okay? And then we need to have controls and system for that. That's why we need to conduct the process hazards analysis and the hazards operability study, sorry, my tongue is wrong. Very difficult. Hazards operability study, something like that. Okay. Later, I will discuss also what is hazard. Okay, but wait, this is process safety management first. Okay, number one element of this process safety management is, oh my gosh, we need to deal with the contractors because all plant, okay, all factory or client or, you know, the first owner have its contractors. Okay, a plant owner also will never survive without the contractors. Okay, because that is the only way to save the cost. Okay, that's why they contract those people and to make also the job fast. Okay, something like that. Okay, and saving costs, something like that, manpower. Okay, so contractors. Okay, this is one element, contractors. Okay, number two, I don't have to discuss because too much because there are 14, right? So 14, I discuss everything, then it will reach morning. Okay. Especially, my character is very talkative. Okay, so not good. Okay. Number two is compliance audit. Compliance audit, this is in here that we need to conduct safety inspection, especially the external party, the government will conduct the safety audit and safety inspection in your site. This is part of the compliance audit. For example, the Civil Defense Department of Government, the SASO, something like that, or the Ministry of Health, Mineral Science Department, like that. Any branches of the government that will conduct an OSH, Occupational Safety Health audits and inspection in your company. So that is a part of compliance audit. Okay, to really ensure that we are still complying the safety requirements from the government, something like that. Okay, we are really compliant, something like that. So that's why we have an element called compliance audit. Okay, like that. Compliance audit. Number three, we are having the employee participation. Okay, employee participation. That's why in every company circular memorandum, it should be properly circulated to the employees. Okay, because they need to know the information because they have the right to participate in any information within that organization under the standards. Okay, so they will never hide everything, okay, or anything. They will always let the workers and employees know because that is really the right of the employees to know, okay, regarding safety, regarding the increases of the salaries or whatever, regarding the health protocols or whatever, okay, whatever, the government safety issues or whatever, anything. So employees has the right to know. Okay, it will not be hide by the management because that is really a law and the process safety management that employee must participate in any kind of information. Okay, so employee participation. So that's why this is employee participation. The employee also is, for example, they will be trained to outside training centers because it is also the commitment of the management to send them to the outside training centers, especially if they are not really that competent enough to increase their knowledge. So they need to be sent in the outside training center. Okay, so that's also part of participation of the employee. Okay, not only that, they also participated in the safety trainings, okay, safety meetings, like that, or any kind of meetings governed by the management, not only limited to safety. So they need to participate because it is employee participation as their right. Okay, like that. Our right, something like that. Employee participation. Okay. Gosh, my voice is cracked. And then we need the management of change. Okay. I will discuss you that we need to have the MOC. Okay. Management of change will arise, especially when there are new equipment introduced in the process. Okay, so of course the procedure also will change because especially if the equipment have another design, so it's no longer the same equipment used before. So you need to adjust your documentation regarding the procedure. Okay, so if there are new equipment coming, if there are new materials that you'll be able to use, okay, for the first time, okay, because that is very new materials to be used and it's not the same as before and it have the same purpose, but only new materials, but it has the same purpose. It will provide the same purpose, but only another materials to be used. So the people did not know that. Okay, so we need to train them, teach them. So that's why we need to have the documentation changes, blah blah blah, revision, and then that's the time we will issue the management of change. or MOC, because there's a lot of changes now. So, okay, not the same before. Okay, if there are changes, but if there's no changes, there's no need for MOC. Mechanical integrity is very important for all equipment, facilities, and technologies used in the process or in the plant. Okay, this is the main responsibility of the mechanical department. Okay, mechanical integrity, because they are the one who let that equipment to be in good condition and operating smoothly and properly, like that, and it runs like that. Okay, then we can purchase another one, to buy another one, because there are things also that too much damage already, we could no longer repair. So there will be a time like that also. Okay, but as much as possible, we will try to repair with the best their ability and knowledge. But time will come also will be like that. Or it will cause delay to our scope. Mechanical integrity is part of process safety management. So that's why we have medical department of process safety management as a communication for the safety. So it's related to process safety management. Okay, we need to investigate, because if you don't investigate, any accidents will be happening, and it causes a lot of losses from the company. Okay, not only for the equipment damage cost, product damage cost, raw materials damage cost, not only that, but to the injury of the personnel, especially the death or the loss of life. Okay, incident investigation. Okay, like that. 7, hot work permit. See, hot work permit is very special. It's considered in the safety process safety management. Okay, specific hot work. Okay, why not excavation? Okay, because this is not construction industry. Okay, hot work permit or scaffolding permit like this. It's always hot work permit in the process. Okay, or in the manufacturing industry. Okay, this one. Number 7, Okay. If you want to take down, then take down also notes if you can, or just put automatically into your brain. No problem. Okay. Number 8 will be the operating procedure or safe operating procedures, just the same. SOP. Okay. And what we call that as the safe work practices. If there will be no safe work practices, then too much damage of the equipment, okay, too much damage of the facilities like this, and too much wastage in the materials or raw materials, okay, so like that, or too much leakages somewhere along to the line to lines or system to system. If there will be no safe work practice, of course, we have to adapt that, okay. Okay, that's number 8. Okay. Number 9, we have the trade secret. The trade secret, that's why it's called secret. It will never be revealed. And the management knows that. But still, this is under process safety management. This is highly sensitive document that should not be shared by anybody and should not be, disclosed. Okay? This is trade secret. All companies all over the world, big or small, has its own trade secret. Okay, as part of the management commitment and responsibility. It will never be revealed. Okay, trade secret. Okay. Number 10 is the training management. This training is not limited to safety, training for all. Training for the electrical people, training for the instrument people, training for the mechanical people, training for the production people, or training to the HR people, all department as the needs arises for the department. Training management, this is a commitment with the management and responsibility. Okay, so that it will increase knowledge to their people and competency, then they can handle their job properly also, and then it can have a smooth output and efficiency to their people and producing a highly remarkable and top caliber product, something like that, okay, that can compete to other companies also that producing the same products. Of course, there's a competition, okay, like that. So this is training management. Okay, number 10, don't worry, we don't have an examination. Okay. This is under listing and listing in the Bush examination. There are so many of list the following, blah, 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 and then outline the following, blah, blah. The outline is more difficult because you need to describe after listing, and you have to describe in sentence to sentence, paragraph to paragraph. But then listing only 1, 2, 3, 4, just like enumeration. You need to discuss, okay, in sentence, only writing, just like this, contractors, compliance. This is only listing, okay, not outline. Outline is very, comprehensive. You said, number 1, contractor, you have to describe contractor, blah, 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 like this, okay? Needs 1 sentence, and then 2, compliance, oh, like this. You need to add description. So that's really the outline, okay? That's forms of examination. Outline, list, enumerate, define, explain, okay, sketch, something like that. Okay. Training management, safety to also have training. So usually in-house training should be a backbone to all trainings. Okay. Before you can create an external training, there must be an in-house training first. Okay. Because there are 2 types of training, internal or in-house training and the external or outside training. Okay. This training management. Okay. Number 11, charot. We have the PSI, as what I mentioned earlier. No need to discuss, process safety information, PSI. Okay. 12, PHA, process hazard analysis. I also discussed, right? PHA. Okay. 13 is hazard. HAZOPS. HAZOPS meaning hazard operability study. Okay, this HAZOPS really, is a structured and a systematic examination of the complex and an existing process or operation, like this, to identify the problems that may exist to the workers, to the work equipment, so that to avoid company losses, to avoid any work-related accidents and injuries, something like that. Okay, that is hazardous operability study. My gosh, my tongue. Okay, so these are only equipment being considered. Equipment 1, equipment 2, equipment 3. These are not considering the raw materials, the people. The hazards are talking mainly with the equipment. Okay, but of course, if the hazard should be in equipment 1, the hazard should be affected to the person, of course. But they will never state that number 1, the people will get this one and put this in. Not like that. Not in a procedure, but the effects will be addressed to the people, something like that. The people and the equipment, something like that. Because hazard is more on the equipment, machine, process equipment, like that. In the process. Process A, process B, process C, process D. Process A, so many equipment, right? So many process equipment, right? Process B, like that. Your hazards will be focusing on that. Okay, so we need to troubleshoot the problems encountered so that it will not produce problems or risk to the personnel or the employees operating that machine, operating that equipment, like that, in a form of document, something like that. Okay. Again, this is collective effort, interdisciplinary approach to be done by the safety department, mechanical, electrical, instrument, production. All departments will sit in one room and to make this document. Okay, like that. Number 14. This is oh my God, pre-startup safety review, or the PSSR. Pre-startup safety review. But if your companies are already running normally and the operation already smoothly, okay, and then this is only before the construction had completed, and then you have to establish the startup. If all the lines to lines are working properly, no abnormalities like this, then we need to conduct the pre before startup, right? So pre-startup safety review. We need to review all the safety parameters of that motor tank, for example, okay, of that tanks, vessels like that, or any kind of lines to lines, we need, or equipment to equipment, we need to have pre-startup safety review. So the safety engineer will be there together with other representatives from other departments also. Okay, the mechanical, production, quality, like that. So it's a teamwork to conduct this PSSR. Usually, this process safety management are teamwork, not individual effort. Okay, so we have now 14 elements of a process safety management. Okay, any questions so far? Okay, if we apply this properly together with the process safety information, okay, then there will be no catastrophic events, meaning deadly events or any major accidents will be happening in the plant or manufacturing company. Especially if you have a very good process safety management, process hazard analysis, okay, like that, and hazards, then bingo, your plant is very safe, and then nobody will get hurt, nobody will get injured, something like that. Okay, though there are minor, but I mean there's no major. Okay, no major. Okay, no loss of life like this. Okay, no explosion like this. No big fire will be happening. Okay, and that's why safety department is created. That's the rule to prevent those. Okay, from coming. Okay, because that's too very expensive and costly if that will be happening. Okay, and it's not easy to recover. Okay, to start again back to zero. Okay, for example, if the whole plant are burning, it's not easy to back to zero to create again another operation like that. Usually, it will be closed, bankrupt, or create another branch of that plant rather than making it again because that is totally damaged. Okay, for example, explosion. But usually, fire and explosion catastrophic events are normally are those plants are gases plants. Okay, gas plants. Okay, that will produce let's say methane gas, propane. Those are highly flammable. Okay, so more or less they are the one who will have, especially the drilling. You know the drilling operation somewhere along in the sea like that, in the ocean. They will drill to get the oil. Oil drilling is the those are really catastrophic event. If they mistake only small one mistake and then all will be exploding. Okay, like that. So that's the problem with oil drilling, gas plants. That's more highly critical. Okay, their products are highly critical compared to the solid substances. Okay, company and factories are producing solid substances are not really that very catastrophic, but those are producing gaseous toxic gas, right? Harmful gases are very dangerous. Okay, especially for the explosion and the fire and explosion risks. Okay, like I mean, the safety department must be very organized and have very adequate knowledge how to prevent and have a very effective safety procedures, like the safety policies for that kind of for those kinds of uh, companies. Okay, though all will be having like that, but their mode of operations are very critical compared to the to those who are producing only soap, like beer, right? Okay. Compared to the gas plants, they're producing highly explosive, okay, and then very toxic, okay, like this. And also explosive chemicals also. Companies who are producing explosive chemicals. Of course, that is explosion, right? Okay. Blasting chemicals. Okay. Producing blasting chemicals products are very dangerous also. Okay, like that. They need to conduct the hazardous, the PHA, like this, and the process safety management is very strong. Okay, like this. I don't have to discuss this one by one because a lot, right? See, this one, two, three, four, five, six. No need to discuss, right? Okay, only overview. This is only an overview to give an idea that it's gonna be like this, in a process plant, something like that. Okay. Thank you so much for listening and watching this live streaming of mine. Okay, this is again, I'm a senior eternal voice. Again, this is engineer Sotero Nepomuceno Jr., OSH engineer and a registered chemical engineer. Thank you so much for watching this live stream. I hope you like, guys, and have a little information gained. And you can share also to anybody else also if you want. And then you can like, you can comment, you can share. And if you haven't subscribed yet, please subscribe to my YT channel. I am a senior eternal voice, all about occupational safety and health, okay, science, okay, personal vloggings, and a little bit of singing, okay, like that. Thank you so much. Thank you so much for listening. All right, thank you so much for watching with Alex TV. Oh my gosh, Alex TV. Oh my gosh, I forgot to monitor my chat screen. Okay. He's asking that I am monetized. Yes, I am monetized already. Sorry. I will end now this live stream. We have another vlogging tomorrow. Okay. And let's go back to biochemistry. Wow. And health science also. I love health science. Okay. Thank you so much, everybody. Bye-bye. God bless.